Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal of chemistry and I'm dealing with the topic thermodynamics. In this topic, this is lecture number 28. Well, in this lecture I will explain you about Carnot cycle. This is second lecture on Carnot cycle. In previous lecture I explained you what is heat engine and how Carnot cycle theoretically can explain the working condition of heat engine. In fact, heat engine works with the four steps. So let us discuss the first step, step 1. Here, in this condition, first step, we will take cylinder which is having a gas and this cylinder is kept in a source X. So gas is a system. The volume of gas is V1, pressure P1 and temperature is T1. This is called source X, which is basically heat reservoir. And here, as it is a heat reservoir, the heat will go into the system from the source. So this way it works. Here the temperature is T1. Now, when heat is going into the system, it is endothermic reaction. The temperature will be T1. As temperature does not changes, it is known as isothermal expansion. It is called isothermal expansion. Okay. So here in this condition, what happened? To the system when it is absorbing heat at constant temperature. So here this is the source X, temperature is T1. Now piston will move upward and will go to V2 and the volume of this system will be V2 and pressure is P2, volume is V2 and here this gas will be expanding at constant temperature. So it is called isothermal expansion. Okay, it is known as isothermal expansion because temperature remain constant, but remember V2 is greater than V1 and P1 is greater than P2. That means pressure decreases, volume increases at constant temperature. So here we can explain it. The cylinder is placed in contact with the source X and the system absorb energy. Here the piston is allowed to move upward infinitesimally slowly so that the gas expand isothermally and reversibly from the volume V1 to V2 at temperature T1, which is constant. And you know that for isothermal process, delta E is equal to 0. And according to first law of thermodynamics, delta E is equal to Q1 minus W1 for this condition or for this process. Therefore, we can say that Q1 is equal to W1. At constant temperature, the work done, because gas is expanding, so work done by the system and therefore it is negative. So W1 will be negative. It is endothermic process. Therefore, Q1 will be positive. So here the formula is Q1 for isothermal expansion. Q1 is equal to minus W1 is equal to 2.303 RT1 log, and volume changes through log V2 upon V1. So this formula is used for isothermal expansion. Okay, so here in the first process, this is happening. Okay, so this way we can calculate work from heat changes. Okay, this is for the first step. Now for the second step, step 2. Here we have cylinder and initial volume is V2. Now this is kept on isolated stand or insulated stand so that it becomes adiabatic condition. Here also what will happen, we will see this. So here a gas was expanded and this is the initial volume V2. The temperature was T1 and here this is a stand. It is an isolated stand Z, okay, or insulated stand Z, and the pressure was P2. This is the condition. Now temperature decreases, so it is no more isothermal, and volume increases because piston is moving upward, so pressure will decrease P3, and as heat is not going outside because it is an insulated system or insulated stand, and therefore it is called adiabatic expansion. So it is adiabatic expansion because without exchange of heat, volume increases, and therefore it is adiabatic expansion, and temperature changes from T1 to T2, and here T1 is greater than T2. Volume changes from V2 to V3, and here V2 is less than V3, and pressure changes from P2 to P3. So obviously P2 will be greater than P3. That means pressure decreases. So this is the condition during this adiabatic expansion. Okay, so now the cylinder is removed from the source X and is placed in contact with the stand Z, which is isolated stand. So, and piston is allowed to move upward so that gas expand reversibly and there is no heat change, so adiabatical. Okay, so this way adiabatically there is no change in the heat, and that expansion is from V2 to V3 at temperature T2. Okay, so as process is adiabatic, for adiabatic process dq is equal to 0 and again expansion takes place, so the work done by the system, so here work done by the system, therefore W2 will be negative, so here W2 is negative. So for adiabatic expansion, we have formula delta E is equal to, heat changes is 0, so dq is 0, so only minus W2, which is equal to minus heat capacity at constant volume into T1 minus T2. So this way, using this formula, we can find out internal energy change or work done during adiabatic expansion. Okay, so that's it. In this lecture we have discussed only 2 steps of Carnot cycle. I have to discuss 2 more steps, but in next lecture. Thank you so much.